Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, graphing your system of linear equations when you have 0 solutions or many solutions. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 9th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 2 examples, so leave a like, smash the subscribe button, and let's get started. So previously on this channel, we covered how you would solve your system of linear equations by graphing. Now, if you missed that and you need a refresher or it's just brand new to you, no worries. I'll link it right up here somewhere, or I might actually put it in the description box as well. However, we talked about what it would look like, what you need to look for when you're trying to graph your system in order to solve it. And that's pretty much just your intersection point. However, there will be plenty of times when you're trying to graph your system and you won't have a single solution. In fact, you may have no solutions, or you may have an infinite number of solutions. Today, we're going to be covering what your graph will look like when you're in either one of those 2 categories. So let's jump into our first example. And I have laid it out here. We have y equals negative 2x plus 2 as our first equation, and y equals negative 2x minus 2. And I've assigned them colors. So we use the 2 colors to graph our 2 graphs. So let's start with our first one because that's the color we chose first. So we're going to go up to 1, 2. And as I did in the previous video, if you're interested in using this type of virtual graph paper, I'll put that link in the description box as well. So we're up 1, 2. And so this is where we start. And we're going to go down, right? Because it's a negative 2. Down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. And we can do the reverse, up 2 over 1, up 2 over 1, and that should be all we need. Now let's graph our other one. All right, so we have negative 2 minus 2. So we're going to start down here. 1, 2, start down here. And we're going to go the same thing. Down 2 over 1. Down 2 over 1. Down 2 over 1. And let's go reverse. Up 2 over 1. Up 2 over 1. Up 2 over 1. And up 2 over 1. So I did a little bit more on this to kind of like drive the point home. So you see these 2 graphs. Our 2 graphs are plotted with 2 different colors here. What do you notice about them? How many intersection points do we have? Well, we have exactly 0. These are actually parallel lines. There's no intersection point, therefore, there's no solution that will work for this. Nothing, no x, no y, will work for both of these at the same exact time. This is an example where you have 0 solutions. This is no solutions. And all of your no solutions will look like this. Now, it might not be exactly like in this form or fashion where it's going down like this. You may have them increasing. You may have them parallel. It doesn't really matter. They're just going to never touch. They're parallel lines. So when you have no solutions, you have parallel lines. When you have one solution, we have an intersection point. How about when we have many solutions, or in our case, because these are linear, infinite solutions? Let's jump into our next equation. Here's our second example. And one of the first things you'll notice is y isn't isolated. Unlike our previous example where y was isolated, in these cases, y is not going to be isolated. So what you have to do first before you start graphing these is to isolate your y, see what you got. So let's try to do that. So our first one, if we were to try to isolate our y, it would be y equals, let me do it black so you can see it a little bit easier. It would be a y, I did say black, y equals an x minus 6. right? That's what our graph would be. That's what our graph would be. So I'm gonna move this over, select this, move it over. I'm gonna move, boom. So when we solve for y, essentially get y by itself, this x minus y equals 6 turns into y equals x minus 6. And let's do the same thing for down here. So we want to, once again, try to get y by itself. So when you do that, you're going to get a y equals, you have 2x minus 12. However, all of this is going to be divided by 2. All of it is divided by 2. And of course you can simplify this. So when we simplify it, we'll have y equals x minus 6. Now, does that look familiar? In fact, it does. This y equals x minus 6 is the same thing as this y equals x minus 6. So you will notice that whenever you have this situation happening, you're really just graphing one line. But let's do it. Let's do them one at a time and see what we get. You should know. You should see it. But let's just do this. So y equals x minus 6. So we're going to start down here at, we're going to use our pink one here, at negative 6. You have 1, 2, 3, 4, 5, 6. And we're going to be going up. So it's going to be, let's get my line in here. 1, 2, 3, 4, 5, 6. Going up 1 over 1, up 1 over 1. This is how our y equals x minus 6, how that looks. Now let's do the same thing. I guess we can go the reverse as well. Just a little bit. Boom. Now let's do our blue. And it's quite honestly the same thing. So we're going to start with here. Boom, boom, boom. Keep it going. And you'll notice it's identical. We're graphing the same thing, so it shouldn't be a surprise. It's identical. That tells you have how many solutions. How many times are these two lines overlapping? Many times, an infinite number of times. This is the same exact graph, so it's going to hit every single point that exists on this graph. This is an example of having infinite solutions, and all of your infinite solution graphs will look like this. You have just the one graph because they're pretty much the same graph sitting on top of each other. So in our first example, when we're graphing our two equations and they end up being parallel lines, that's telling you have exactly 0 solutions for your system. And in this example, if you're graphing your equations and you realize that they're the same exact equation, that is telling you, graphically, is telling you have infinite number of solutions. You're graphing just one equation. Every point satisfies both because they're the same exact equation. You have infinite number of solutions. So I hope you'll be able to follow along with today's video, and I hope you now understand what your graphs will look like when you have no solutions and when you have an infinite number of them. However, if you have any questions about what we saw today, or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework. Look forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.